Our speaker for today is Alyson van Raalte from the Max Planck Institute for Demographic Research, where she leads the research group Lifespan Inequalities. Alyson's research interests include lifespan variation and socioeconomic inequalities, and in 2022 she was the recipient of the Mid-Career European Demography Award from Population Europe. And today she'll be presenting her work on mortality inequalities in SES groups and their families. So I'll hand over to Alyson now to get started.
Well, thank you very much for the invitation. It's a pleasure to be here, at least virtually. I'll just go ahead and share my slides here now. Okay. I assume everybody can see the full screen here?
Yep, we can see that. That looks great.
Perfect. Okay, just hide some of this stuff so I don't have to see it. Okay, so today I'm going to talk about mortality inequalities and socioeconomic, various socioeconomic groups, as well as in their families, but mostly I'll be talking about sort of trends that we are seeing in Europe at the aggregate level. Here. So yeah, we'll start with just discussing this sort of concept of lifespan inequalities, what actually it is and what I'm talking about, and how these are patterning across educational groups in Europe. And then in sort of the last part of the presentation, I'm going to talk a little bit more about some of the implications of these lifespan inequalities, in particular about what this means in terms of the heterogeneity and family mortality patterns by level of education. But this part is a little bit more preliminary. So let me just start with a brief introduction. So here we have age at death distributions from a life table in two periods. You can think of two different populations, the red and the blue population, men and women, two different countries. And we can see that over the two periods, there have been changes to both distributions. And the question is, how should we describe the changes in inequality between these two periods? So most research up till now has tended to use measures of central tendency. We talk, for instance, about widening or narrowing gaps in life expectancy between the populations. Epidemiologists tend to use standardized death rates, but that's also, of course, a mean outcome. But we could also talk about differences in the spread or the distribution, and this is what I'm mostly going to be focusing on here. So here we can think about either the variability in the ages at death, or maybe the prematureness of mortality. But in any case, we're getting at this idea of deaths happening over a wide age range. This is sort of important because it speaks both to the heterogeneity of the population group itself, as well as the uncertainty in the timing of death. And then the third sort of types of measures, which don't get used too often, but I think are really also quite important, are measures of statistical distance. So for example, the Kuhlbach-Leiber divergence. Could also talk about out survival probabilities. What are the chances that someone in the blue distribution out survives the person in the red distribution? And different measures of overlap. For instance, Zhazhen Shi and colleagues had a nice paper recently in population studies about that. And then, of course, there are other things we could talk about, skewness or kurtosis. I haven't seen anyone do that, so, but it might be interesting. In any case, my aims today are to sort of more fully describe changes in mortality inequalities by socioeconomic status in Europe and the United States, and more broadly to try to convince you that it's worth looking beyond the mean when measuring inequalities. Okay, so inequalities exist beyond mean differences. Here we have trends in life expectancy on the left and lifespan variation, in this case measured by the standard deviation on the right, for Finnish females by different levels of education. Now, Finland is used because they have register data going back to the early 1970s. So we have 50 years of trends, period trends, which is almost impossible to do in almost any other population. If we look just at the figure on the left, the life expectancy figure, we see that all of the educational groups have experienced increasing life expectancy over time. a good thing. And in fact, that the differences have moved more or less in parallel with one another. There might have been a little bit of widening, but I think the main takeaway message is that the low educated, for the most part, are following behind the high educated groups with a bit of a lag. When instead now we turn to the figure on the right, describing the lifespan variation, we're seeing a totally different story here. The low educated are experiencing increasing lifespan variation, while the high educated are experiencing declines. So what this means is that the low educated group are becoming more heterogeneous in terms of their health and mortality over time. You can also think about it at the individual level, that the timing of their death is becoming more and more uncertain over time. And the opposite is happening for the high educated groups. Their mortality schedules are happening in a narrower and narrower age range over time. So their deaths are becoming more predictable. The question, is this a universal pattern? So we have tried over the past few years to gather as much data as we can across different European countries as well as the United States to see if we can replicate this pattern that I showed you in Finland. Mostly here I will be showing you data from the LifePath project. We're just in the process of updating it a little bit more recently, but unfortunately I didn't get that finished before this presentation. So I think the data that I have now will go until around 2015. And we have also updated the data from the United States that was used in Isaac Sasson's publication. So Isaac is a co-author here in this project. And they don't completely compare to the European educational categories, but we are still sort of use a low, medium, and high education group for the United States. So I showed you the pattern for Finnish females. Now I think it's time to turn to men. I should mention that the pattern for Finnish men look roughly similar, and these patterns that we see that I'm showing you with men are fairly similar for females as well, but just the levels are a little different. I think, well, we can look already at the panel for Finland, and the trends are as they were for females, so that all groups are experiencing increases in life expectancy. There's maybe been a little bit of widening in these differences over time. And I think this seems to be a pattern that is replicated across all of the different countries. Now, some countries have larger differences between the high and low educated. And one must also remember that the distributions themselves can be quite different across these different countries. Meaning in some countries, just because of their educational system, a lot more people end up in high educated groups. Or conversely, that the low educated groups are much smaller. And there's also been quite substantial differences across countries in terms of the pace of the educational transition. Yet on the other hand, we are looking at these patterns in education across countries because education is the variable, the socioeconomic variable that we have most plentiful across countries. Now turning to lifespan variation. Again, here I'm using the standard deviation in age at death. And well, we saw already the Finnish pattern for females. Here's the Finnish pattern for males. And it's sort of the same thing, that there were very few differences in the early 70s, and these have widened substantially. Finland does seem to be on the more extreme end of that pattern, but in every country, we do tend to see that the high educated groups are experiencing declines in lifespan variation, whereas the low educated groups are experiencing increases. This can be seen more carefully, I think, or more easily when we sort of drop the different panels by country and just group all of the populations into high, low, and medium educated. The colors here refer to the year in which the dot, takes place. And then when you see a couple of dots joined by a line, this refers to one specific population. So for some populations, we only have 2 data points. For other populations, we only have 4. But the main thing that I want you to take away from this figure is that among the high educated, there's actually very little variation across countries. All of them seem to be moving sort of from the yellow direction towards the dark blue direction, meaning that over time, they're experiencing increasing life expectancy, or average ages at death, and declines in the standard deviation. If we compare that to the low educated group, first, there's a lot more variation across countries. And secondly, if anything, the trend is going in this direction, meaning that, you know, the populations are experiencing increasing average ages at death, but doing so with increasing standard deviations in the survival age. And the medium education group is something in between, as is then the total population. Now, the standard deviation is a marker of absolute inequality differences. You know, it's an outcome where the differences are in years, it's the standard deviation. But what about relative inequality? Does it matter if you have a standard deviation of, in this case, 11 to 14 years, when the life expectancy itself is different? So any measure of inequality, so far I've shown you the standard deviation, but we could also use measures out of the life table, like the life disparity measure. We could use different quantile-based measures like the interquartile range, etc. Almost all of them have a relative inequality corresponding metric. So the standard deviation, when we divide it by life expectancy, that's the coefficient of variation. The Gini coefficient, which we use very often, the absolute counterpart would be the absolute individual difference, meaning that if you have a Gini or an AID of 12 years, on average, 2 individuals will die with 12 years of difference in life expectancy, etc. Absolute measures would remain unchanged if everyone's life increased by the same amount in years. We call this translation invariance. Whereas relative measures mean that the value would remain unchanged if everybody's life increased by the same proportion of their life. Now, I'm not sure that we should prefer one type of inequality over the other, absolute or relative. They both probably have their parts or their places. Economists tend to use relative measures when they're looking at economic distributions, partly because there's such a huge difference in incomes across countries and between the high and low income groups. Whereas for relative measures, or sorry, for lifespans, the differences are not so large. So I think some of the arguments for using relative measures are a little bit weaker in our case. And then the other challenge when we're looking at relative measures is it's not actually even clear what we should put in the denominator. So should we use, when we are measuring the entire distribution, for example, here I have plotted the age at death distribution for Russian men in 2014. If we measure the entire age distribution from birth, we would have a mean age at death of 65.3 years, which is that dotted line. But in the event that we make this metric conditional upon survival to age 30, well, then the mean age at death conditional upon survival to age 30 is 67.5. But what if instead of looking at age at death in the x-axis, we look at remaining life expectancy? As you can see, these are exactly the same distributions, and the value will just differ by the age at which we are conditioning survival upon. So in the first case, we call these attainment distributions, the attained age. In the second case, we call it shortfall distribution, how many years of life remain. Now, of course, particularly when we're looking at older ages, like for example, 65, it will make a massive difference if you put 78.2 or 13.2 years in the denominator. Not so much, this is especially the case when we're looking at differences over time, because the proportional difference over time for a attainment distribution will be much smaller than the proportional differences over time from a shortfall distribution. I'm saying this because this will actually also impact what we see when we look at these different metrics. And this is something that people haven't paid too much attention to up until now. So most of the researchers, including myself, working in the fields of lifespan inequality, when we have used relative metrics, sometimes we've used attainment distributions and sometimes we've used shortfall distributions. And it seems to be a little bit of a path dependence depending on who first worked out what the formula should be from a life table, rather than for any normative reason. So here I am looking at the coefficient of variation, and on the left we have the achievement distribution, meaning that in the denominator we have the average age at death conditional upon survival to age 40, or E40 plus 40. And on the right, we just have E40, so the remaining life expectancy at age 40 in the denominator. And when we have remaining life expectancy in the denominator, the trends over time are quite dominated by what's happening in terms of that denominator, because it'll be a smaller number and it'll change to a larger degree proportionally, meaning that we don't have as much variation across countries as what we saw when we looked at the standard deviation. Moreover, in all cases, we see declining lifespan variation with increasing remaining life expectancy. So when we use an attainment distribution, the trends are somewhat in between the two. And I'm saying this just to sort of be a little bit honest and not to make it look like we're cherry picking when we first show those first figures that look at the standard deviation. So far, I've mainly been talking about education, but it's likely that these sorts of patterns are also being found by other markers of socioeconomic status. Unfortunately, we just don't have this kind of data for most countries in the world or in Europe. But for example, in Finland, where we did, these were the patterns we had for education. For occupational class, which has experienced much less, where the distributions themselves have changed much less over time. You know, I think the manual groups changed from something like 50% of the population down to 40%, whereas the upper non-manual have maybe doubled in size. You still see a very qualitatively similar pattern to what we do with education. So this isn't just an issue of compositional change. And then income quintile, where the size of the groups are the same over time. Again, I think you see a qualitatively similar pattern that the low income quintiles are experiencing increasing variation and the upper income quintiles are experiencing declining variation. But income, of course, suffers then from endogeneity problems, in that your income sometimes declines in the years before you die, as you are unable to work. We've also looked at area level deprivation in Scotland. So this was led by Rosie Seaman. And here, this is just looking at lifespan variation, and it's looking at a different measure, the E-Dagger measure. And this has the advantage that we didn't have to condition it upon survival to age 30, so we are looking from birth. And again, here in Scotland, we saw that the lifespan variation widened across quintiles of deprivation. And this was measured using the Carstairs score. For females, the pattern was a little bit less clear, and it does appear like in the more recent decade, from 2001 to 2011, there might have been actually some declining lifespan variation for the lowest income quintile. So patterns aren't exactly the same as they are at the individual level, socioeconomic status. So to sort of summarize these broad level trends, we find that inequalities in mortality by level of education are stable when measured by life expectancy, but increasing when measured by lifespan variation, and not just increasing, but also going in different directions. And that disadvantaged groups are reaching higher average ages at death with more within group inequality than their advantaged group counterparts had when they experienced that average age at death. But this is clearer for absolute measures of inequality than it is for relative measures. And I think these sorts of results have some pretty deep-seated implications. So at the population level, that shows that disadvantaged groups are becoming more heterogeneous. And this seems to parallel a lot of other heterogeneities we see in the life course. So in some senses, this means the average is less meaningful, and that there's probably been an awful lot of compositional change that we maybe do not fully understand that is happening within all of these different types of groups. At the individual level, death is becoming less predictable for some, but more predictable for others. Now, I didn't go into this so much, but we also see growing stratification when you look at the distributions themselves. So they're pulling themselves apart, meaning that if you are in an advantaged group, you might have very little exposure to premature mortality compared to those in disadvantaged groups. And this sort of brings up questions about social cohesion. If the policymakers themselves are all coming from advantaged groups, is there still going to be the same desire to enact population health policies that might not personally affect them or their families? And it also calls into question some of our age-based policies, for example, pensions, because life expectancy captures, the remaining life, but not actually the proportion surviving to retirement. And in some work we have done on the United States, there are actually pretty substantial differences in the proportion surviving to retirement by level of education. And finally, I think what I'm going to get into next is that it's highly likely that among the more disadvantaged families, they're experiencing a much higher level of premature or surprise mortality, including, for example, mortality falling out of the generational sequence. And these sort of surprise deaths might be far more consequential than experiencing deaths of older family members at a more expected age. So this brings me to the last part of the presentation, where we are trying to look at some of these questions using Swedish registry data. And we ask whether higher lifespan variation means more uncertainty in when family members will die. So it might seem, at first we were kind of hypothesizing that yes, disadvantaged family members, they're far more likely to see more mortality and to see mortality at younger ages. But on the other hand, it's a little bit unclear what happens within a family structure because there are socioeconomic differences in mortality, but there are also pretty strong socioeconomic differences in kin structure. In particular, disadvantaged groups very often have shorter generational lengths. So even if, for example, their grandparents might be 10, 15 years younger on average than the more advantaged groups or the highest educated groups, and some of these differences in kin structure and generational length might actually mean that the death rates are more comparable. And also there have been differences in fertility patterns and differences in family sizes themselves. So we are arguing that there should be a new framework to quantify bereavement patterns. We're calling them bereavement patterns. So the deaths of a focal individual, the deaths that they're experiencing in the family. And we think these should be sort of quantified in terms of either intensity or predictability. So intensity would be the number of deaths of family members experienced by an individual at a certain age or by a certain age. While predictability is referring to sort of the deaths of parents, siblings, cousins as a child that are experienced sort of at younger or unexpected ages. It could also mean things like deaths falling out of the generational sequence. And so far we are looking just at families, but these sorts of frameworks could also be applied to other types of social networks. So using Swedish registry data, we have sort of quantified the bereavement patterns by age of a focal individual. And here these colors refer to the different type of kin. Any of these counts that are above the 0 line mean that these deaths were experienced more in the basic educated group compared to the tertiary educated group. Deaths falling below the 0 line, in this case by grandmothers and grandfathers, mean that there were more of these types of deaths at these ages among the high educated or the tertiary educated compared to the basic educated. And this is average yearly bereavements. So what we can see is that at a young age, there actually isn't a very large difference between the high and low educated. The red line is the aggregate over all kin types, but they start ramping up basically in early adulthood, and they ramp up because of really large differences in one generation higher. So the mother, father, aunts, uncles, but then there are also increasing differences in terms of in-laws and then siblings, half cousins. siblings, half-siblings, and cousins. Whereas on the other hand, at almost all ages, the high educated groups experience more deaths of grandmothers and even to some extent grandfathers as well. If we think about this in terms of predictability, well, we can consider deaths in the grandparental generation as being sort of more predictable deaths. So sort of something that you expect to experience at some point in your life course. Here we're looking at the cumulative number of deaths experienced by children up to the age of 18, whereas unexpected deaths would be among those in the contemporary generation, so siblings and cousins. And the parental generation is the generation coming in between. Now here I've switched from education to income, partly by accident, but the story is qualitatively similar. We looked at both education and income. And the main takeaway point here is that among the predictable deaths, there actually aren't very large differences between income groups. But within the contemporary generation, the lowest income quintile has a much higher odds of experiencing a death among the contemporary generation up to the age of 18 than the highest income quintile. So even though these deaths are rare, they just affect the more disadvantaged groups far more frequently. So our next project, we're sort of going to try to build on that, and we're actually, in this case, going to use modeled kinship structures using Finnish register data. And there we will do, instead of this last one was, I should have mentioned, one cohort. So it was the cohort of 1973. But here we are actually interested in looking at how these things are trending. So we're going to do period data using the entire landscape of the Finnish register data. And then we will sort of break things up into both the intensity of kin death as well as the predictability. So the intensity being expected kin death counts by each age, and the predictability being the variance in ages at death of kin and deaths that fall out of the generational ordering. So that's basically it, what I wanted to show you, and I'm really going to open the floor to questions and welcome any questions you might have. So this is sort of based on two larger projects. The first one is using data with the LifePath Consortium, and I'd like to thank my co-authors listed here. And in the second one that's looking at sort of the family and kinship networks, this is working together with Isaac Sasson, Linus Anderson, and Diego Alburas Gutierrez. So thank you, and stop sharing and open the floor to questions.